Right. Okay. I'd like to have a quick little lecture on remote sensing, even though this isn't a remote sensing course, but it is relevant as it is the two technologies of GIS and remote sensing are related to each other. One is remote sensing is designed more for collecting data, but that collected data can be used within a GIS. So let's talk for a minute about remote sensing. It's defined as a science and art of obtaining information without being in direct contact with it. Information can be collected from both orbital platforms in space, suborbital platforms, including airplanes and helicopters, and more increasingly with drones. Drone technology is really emerging as a new type of increasingly popular remote sensing platform. So to understand the remote sensing, one way to contrast it is with in situ or field-based measurements. Although it should be said that the field-based measurements on the ground, are an important aspect of remote sensing, because to understand what you're collecting from a distance, you also have to collect information on the ground to compare the two together. So think of remote sensing as a step before GIS. We've talked about data collection in the past, and remote sensing is a good example of a massive scale data collection from a remote platform. So GIS is used to analyze spatial data, and remote sensing is used to collect new spatial data that can then be analyzed. And the two overlap. So most remote sensing platform software, there is software that is specialized for working with remote sensing data. Some of it very unique to different kinds of satellite data, but some of it to do some simple analysis or complex analysis. But that overlaps with raster-based analysis in GIS, because the information collected in remote sensing is often a raster data set. So for example, remote sensing has vegetation indices. I like to tell you something about the relative amount of vegetation in a place across different bands of data. And if you took the processed satellite information into a GIS, you could do similar types of analyses. So here's an image of California with two bands of a satellite called MODIS, and we'll talk later about some of the different satellites. And this one is the red band. This would be what our eyes normally see as red, and this one is in the near infrared, and this is kind of beyond what our eyes can see. But for physical reasons, the way that it reacts with plants, plants are much brighter in the infrared than they are in the red. Plants absorb the color red, but they reflect what you might say is a color infrared, even though it's not a color that our eyes normally see. This is something that the satellites can detect. So here in the valley and along the coast range, where you have a lot of vegetation, a lot of that vegetation will absorb the red light, and that's why it's darker here. But at the same time, these same areas, note that they are much brighter in the near infrared. And because of them, and then so say things like snow, though, snow is both bright in both the red and the near infrared. So specifically, vegetation is different in the infrared than the red. And there is let me see if I can move myself here. There is a common measure called the normalized difference vegetation index. And it's calculated by looking at the ratio of the red and infrared. So it's like the infrared minus the red divided by the infrared plus the red. And that gives you a scale from -1 to 1, 1 being most vegetated and -1 being the least vegetated. Although in what we tend to do is then scale that from 0 to 255. So it's easier to, it's just a more efficient number format to store in a computer. It's not the best measure of vegetation, but it is very simple and very commonly used. So it's when you're learning about remote sensing and things like vegetation indices, this is kind of like the first one. It's like the most basic one. But however, people who are into remote sensing, they have other more complicated indices that can be more complex, less simple to explain, but may do a better job. And like GIS, the remote sensing process is something where you need to identify the problem, like a spatial question that we talked about earlier. You also have to do data collection both in the field and with the remote sensing, because you need to have a way of either what we call calibrating, like adjusting it to actual conditions, and also to be able to check for errors and that type of thing. Then you take the actual remote sensing data and convert that to information. So different kinds of processing techniques to let you do things like take raw data and come up with something like a vegetation index. And then, of course, information presentation, like we do with maps in GIS. You do similar processes with remote sensing data as well.